गुड मॉर्निंग बच्चों। तो आज हम लोग अपना सेकेंड चैप्टर का वही टॉपिक कंटिन्यू करेंगे, एसिड बेस इंडिकेटर। तो कल मैंने आपको स्ट्रॉन्ग एसिड, वीक एसिड, स्ट्रॉन्ग बेस, वीक बेस, ये चारों के रिगार्डिंग बोल दिया, और ये भी बोला वो लोग डिसोशिएट तब करते हैं जब उनको आप पानी में डालते हो। तो देयर इज़ द रीज़न बिकॉज ऑफ इट दैट यू विल लर्न इन हायर ग्रेड्स। ओके, तो कल इंडिकेटर्स भी थोड़ा मैं बोला था, नेचुरल इंडिकेटर्स, सिंथेटिक इंडिकेटर्स। ठीक है, तो स्टार्ट करते हैं अभी। ठीक है, तो टॉपिक्स टू बी कवर्ड, हमारा पहला टॉपिक चल रहा है। तो आइडेंटिफाई कैसा करना है कि इफ अ सब्सटेंस इज एसिडिक और बेसिक इन नेचर। सो यू नो वन कुड से आप पीएच मीटर यूज़ कर सकते हो, आपके लैब में होगा पीएच मीटर। इजी वे, हैंडी वे। तो पीएच मीटर तो सब लोग अफोर्ड नहीं कर पाएंगे बिकॉज इट्स काइंड ऑफ एक्सपेंसिव, तो आप लोग इसको भी यूज़ कर सकते हो। आपका हो गया लिटमस पेपर। तो लिटमस पेपर को अगर आप एसिडिक सोल्यूशन में डालोगे तो रेड विल स्टे, रेड लिटमस पेपर विल स्टे रेड लिटमस पेपर, ब्लू विल चेंज टू रेड। ठीक है, और फिर बेस पे आपका रेड ब्लू को चला जाएगा, चेंज हो जाएगा, और आपका ब्लू लिटमस पेपर ब्लू ही रह जाएगा। ओके, तो दिस इज़ वन मोर वे। और एक वे है हाई, या श्रुति, अनदर वे इज phenolphthalein. Okay, so actually I made an error in previous classes. I was missing this L. It's not phenolphthalein, it's phenolphthalein. Okay, so basically you need a substance which can show you visually that what is the nature of the substance. तो आपका लिटमस पेपर आपको विजुअली दिखा देता है कि एसिडिक है या बेसिक है। ठीक है, फिनोल्फथलीन ये एक सिंथेटिक इंडिकेटर होता है, सिंथेटिक। ओके, सिंथेटिक वाई बिकॉज इट इज सिंथेसाइज्ड इन अ लैब। लिटमस आपका नेचुरल इंडिकेटर होता है क्योंकि इट इज सिंथेसाइज्ड फ्रॉम लाइकेन। ठीक है, तो इसके रिगार्डिंग थोड़ा और पढ़ेंगे कमिंग स्लाइड्स में। तो यू नीड अ सब्सटेंस विच शोज यू विजुअली व्हाट इज़ द नेचर ऑफ द सब्सटेंस यू वांट टू नो। तो ये थोड़ा आपका टंग ट्विस्टर टाइप हो गया, बट एनीवे, तो यू नीड अ इंडिकेटर। इंडिकेटर्स आर सब्सटेंसेस विच इंडिकेट द एसिडिटी और बेसिसिटी ऑफ अ सोल्यूशन। ठीक है, कि आपके केस पे आप लोग सोल्यूशंस के साथ ही इंटरेक्ट करोगे, तो इंडिकेटर आपके इंडिकेट करता है एसिडिटी या फिर बेसिसिटी ऑफ अ सोल्यूशन। ओके, तो चलिए नेक्स्ट स्लाइड चलते हैं। जैसे कल हम लोग हाइड्रेंजिया देखे, टर्मरिक देखे, तो आज और थोड़ा पढ़ते हैं। ठीक है, नेक्स्ट चलेंगे तो एसिड बेस इंडिकेटर्स, केमिकल सब्सटेंसेस विच हेल्प इन आइडेंटिफाइंग द एसिडिक और बेसिक नेचर ऑफ सब्सटेंसेस। हाय राज, तो एसिडिक और बेसिक नेचर ऑफ सब्सटेंसेस आपके केस पे सोल्यूशन ही होगा, क्योंकि आप लोग को कैसे सी वॉट एवर यूर स्टडिंग उसका आपको लैब में उसके रिलेटेड कुछ एक्सपेरिमेंट करना पड़ेगा। ठीक है, टेस्ट ना, नेवर टेस्ट एनीथिंग। yeah, it's kind of a pun, but do not taste or even smell, because concentrated acids like HCl, they are vapors, they easily vaporize, so you will have HCl vapors coming out. So if you smell that, it will go into your lungs and kind of melt it. Melting would be the correct word. Okay, so taste, smell, or even your touch. Okay, acids and bases are very corrosive substances. Their application is generally to clean stuff. Okay, मतलब जैसे आपका कॉस्टिक सोडा हो गया NaOH, उससे आप क्लीन करते हो, तो क्लीनिंग द स्टफ दैट दे क्लीन, दे आर नॉन लिविंग सब्सटेंसेस। ओके, तो now acid base indicators are classified into natural or synthetic indicators. Natural are ones which are derived from nature. Yeah, acid is sour in taste and base is bitter, but edible acid like vinegar acid in small amount you can taste. Bitter, you can taste baking soda. Baking soda is little bit bitter. If you will taste it, you will get a sensation of bitterness. Again, even when you are tasting these edible acids or bases, now baking soda, last class I had told you, it is a basic salt, not exactly a base, it is a basic salt. Now taste them in very minute quantity, because even that can cause digestion issues. some issue with your digestive system. Then the natural indicators, they are what? Turmeric. Okay, you got vanilla, phenolphthalein. Turmeric, vanilla is your natural indicator. Phenolphthalein, methyl orange, litmus is also your natural. Okay, so these all are your synthetic indicators. Okay, yeah, red color. And litmus, turmeric, vanilla, they are all your natural indicator. Natural, why? Because you can see it in nature. So we will focus more on litmus. Okay, so basic ones I will tell you. Okay, so your the ones which you will find in your lab, they are these three: phenolphthalein, methyl orange, and litmus solution or litmus paper. Litmus paper is basically, when they manufacture litmus paper, in paper they sort of make a, the paper absorbs some amount of litmus solution and they add some acid to it. So litmus solution is actually purple in color. In neutral it will stay purple. Okay, but your litmus paper is either red or blue. So they achieve that redness or blueness by adding, when the paper is absorbing this litmus solution, so it will become purple. Okay, yeah, releasing of H plus ions. So these H plus ions kind of interact with the, so these all these indicators, they are also chemical substances. They interact with the H plus or OH minus and they undergo chemical reaction, and the color change is a byproduct of that reaction. Okay, the color change is a byproduct of that reaction. Okay, so that is the scene. Then litmus paper is like, when they make litmus paper, they add some acid to this litmus solution, so it turns red. So this red solution then is absorbed onto the paper and then it is dried off. So that gives you that that red litmus paper. Or blue, in the case of blue litmus paper, they add some base to this purple solution. So litmus solution in a basic solution turns blue from purple. So then it gets absorbed to that paper and that paper is then turned into blue litmus paper. So litmus paper and litmus solution are basically the same thing, just shades are different because of addition of an acid or a base to the paper. Okay. Then your methyl orange, what it does is, methyl orange is a orange small, in your lab you will find a small bottle will be there, it will be orange color one bottle, that is methyl orange. It is an indicator. It shows yellow color in base. Okay, yellow in basic solution, and it will show red color in acidic solution, red in acidic. Okay, then your phenolphthalein, it shows pink in basic solution, pink in basic, okay, and colorless in acidic solution, colorless in an acidic solution. Okay, so all three you can find in your lab. Okay, litmus solution, methyl orange solution, then phenolphthalein solution. You can do this experiment also under the supervision of your lab assistant or your teacher. So it is an easy experiment to do. Okay. Next slide will go. And last class turmeric also I had said. So turmeric is your red orange in basic. So when you try to clean a turmeric stain by soap, it turns into red orange stain from yellow in basic solution, because your soap contains NaOH. Soap contains caustic soda in small quantities, that is why it turns to red orange when you try to remove the turmeric stain. Okay, and it is yellow in acidic solution. So turmeric retains its color in acidic solution. Okay. So these are the indicators which you will find in lab and in your house. Okay. Next slide will go. Click here to see the effect of phenolphthalein. So phenolphthalein is a colorless solution. Okay, so you will find a small bottle. Indicators are generally stored in small bottles, about the size of a cup syrup bottle. Okay, about this much. So you will find a colorless solution of phenolphthalein there. So here is a solution of acid. Let's say dilute HCl. So I tried, but the color didn't change. Okay, maybe concentration. So see, certain soaps are actually getting rid of NaOH. Like these days you have certain soaps that do not have any basic nature. It might be a soap which is sort of like organic soap or something which does not have a basic nature. It might be a neutral solution. So maybe, okay, so maybe it did not change color, that's why. So read the constituents of soap. So at the constituent thing, back of the packet or the bottle, you will see constituents. So if no basic substance is there, then color change won't happen. Okay. And or maybe the turmeric that you have, you did not prepare a concentrated enough solution. So these two things you have to figure out. But in general, it will change. Red, orange, it changes. So find a soap which has a base in it. Okay. Maybe sodium hydroxide, maybe some other substance. So check. Okay. So anyway, if I click on this, phenolphthalein is a colorless solution. In acidic solution, it stays colorless, but in basic solution, it will change to pink. You will actually do an experiment in 11th, okay, 11th grade using a pipette burette, okay. So you will do an experiment of titration. So in that experiment, of titration, you basically do a neutralization reaction to know the concentration of either the acid or the base. When you know, so there is a acid and there is a base. So one concentration you know, acid concentration you know, but base concentration you don't know. So to figure out the concentration of the base, unknown solution, you use titration. So in titration, indicators are used, and one of them is phenolphthalein. So in 11th, I think the first experiment, if you study science, you will do is this. You will use phenolphthalein. Okay. Anyway, now also you can ask your chemistry teacher. It's she can show. So for a single class, she can show it. Anyway, our animators have done this animation. So this is a basic representation of the same. Turns pink in color when added to a basic solution. Okay. Click here to say addition of methyl orange. So methyl orange is sort of a orange color liquid. Again, a small bottle, they will have methyl orange. If you see, okay, if you add it, acid solution, it will turn red, and it turns yellow in a basic solution. Okay, again methyl orange also you will use in a titration experiment. Okay, all these indicators will be used. So mainly you will use two actually, phenolphthalein and methyl orange. These two are used. One more is there, K-MnO4. So potassium permanganate is sort of a self indicator. So that I have explained in the previous classes. Okay. So these three you will be using in 11th grade when you will do lab experiments on use of indicators in everyday life, everyday scientific life. Okay. Next slide will go. So universal indicator. So universal indicator is actually sort of like it's a mixture of various indicators. So it gives you a wide array of colors. Okay, you know our other indicators, they are very black and white. They are giving either pink or colorless, or they are giving us yellow or red. So to give all shades, you will need something. So that is the universal indicator. Okay, so universal indicator is actually a mixture of various substances. Okay, various indicators. It is a mixture of methyl orange. Okay, methyl orange. Then you have phenolphthalein. Okay, and so other substances are also there in the mixture. So universal indicator is basically a mixture of various indicators. Okay, so it gives you the color scale of acids and bases, you know, all the shades. Your methyl orange or phenolphthalein will only give you black or white, like in the case of methyl orange, red or yellow, or in the case of phenolphthalein, colorless or pink. So to have a different array of colors, you use a universal indicator. Okay, so in universal indicator, this is your neutral. So neutral solution with pH. So this is your pH. This x-axis is your pH. Okay, pH is negative log x. pH is minus log of H plus ion concentration in a solution. Okay, so H plus ion concentration is calculated by a pH meter. pH meter is sort of like an electronic device which measures the H plus ion concentration in a solution. So you and the pH meter will only also give you the pH. So it will automatically calculate this. So once you get H plus value, you can calculate minus log of H plus. Logarithmic is a mathematical function. Okay, it is the inverse of exponential function. I had told in last class. So basically, if you have y equal to a to the power x, okay, so a is a number, x is a number. So so it's sort of like, okay, x equal to 2, y equal to 4. Now if you want to find what is the exponent from the answer, you have to do log of 4 base 2 equal to 2. So it is an inverse function of exponential function. Okay, so let's say you are squaring or cubing or quadrupling, so any power you are giving. So if you want to calculate what is the power to which a number has been exponent, has been multiplied several times to get what is the answer right now. So reverse, you will use logarithmic function. Okay, you will read it in 11th. Just remember, it is the inverse of exponential function. Okay, so this is your pH. So as pH increases, basicity happens. Okay, so here it is a strong base. At 14 it is a strong base, and here it is a strong acid. Okay, and in the middle, you have, so this one is strong acid. Sorry, the blackboard just went away. Strong acid. This one is a neutral solution. Sorry, neutral spelling is wrong. This one is a neutral solution, and this is a basic solution. Okay, so pH is from 0 to 14. Okay, so so as you go right, basicity increases, and as you go left, acidity increases. So universal indicator will show these colors, okay, with the respective pH, whatever will be. So if it is in a strong acid, it will show you deep red color. If it is in a strong base, it will show you deep purple color. If it is in a neutral solution, it will show you green color. Okay, so this color map you get from universal indicator. Universal indicator is a mixture of various indicators like phenolphthalein, methyl orange. Okay, some more components are also there, but at your level I think it's not required. So just remember various indicators, two of them, methyl orange and phenolphthalein. Okay, next slide will go. So it is a easy question. Select the model that represents a natural indicator. So natural indicator is any indicator that is derived from nature. Okay, so so anything synthesized in the lab is a synthetic indicator. So you have to basically select the option which is an indicator which derived from nature. Okay, so here obviously turmeric will be my answer. Okay, next slide will go. Next, again a easy question. Question is, connect the bubbles to identify the color change of methyl orange in different solution. So methyl orange is red in an acidic solution, is yellow in a basic solution. Okay, so orange juice contains citric acid. Citric acid is an acidic substance. So obviously methyl orange color will change to reddish orange. Okay, then soap solution is basic in nature because it contains substance like sodium hydroxide, so it will be yellow. Okay, so submit. Okay, so solution is showing the same answers. spicy food acidic in nature. Okay, so let's study regarding this. So what is that? Your spicy food, it contains a substance not called capsaicin. Okay, capsaicin. So its structure is a little bit complicated. It's a organic molecule. Okay, so chilies contain this substance. Okay, chilies, they contain this substance, and it is acidic in nature. Okay, it is a acidic substance. Thus, spicy food is acidic in nature, and if you consume too much chili, okay, it can cause acidity, because it will increase the acidity of your stomach, and then you might have to take some measures to control it. Okay, so the spiciness of our food is because of acids present in them, basically chili. So to make a food spicy, you have to add chili. Now chili has capsaicin. Okay, so it is a everyday so basically it's your tongue acts as an indicator in this scenario. So it gives you the taste of spiciness, and then you have mucus, then you have maybe tears. So all these are because your neuron receptors in your tongue, they are sort of interacting with this chemical capsaicin. Okay, next slide will go. So lichens occupy about 6% of land surface. Lichens you can find on forests. If you go forest area, you can find lichens. Lichens is actually a symbiotic species. Okay, I think everyone knows what is a symbiotic relationship. Okay, lichens is a symbiotic relationship between algae and a fungus. Okay, algae and a fungus. Okay, so here algae, so they both are in a symbiotic relationship. Algae provides the food to the fungus provides the shelter and water. Okay, so they both benefit from this relationship. So it is a symbiotic relationship, and from this lichen you extract your litmus solution. So as lichen is so abundant in our earth's surface, so that is why litmus paper is kind of cheap, because so much is being produced, so the cost will reduce. So any substance which is mass produced, the cost generally reduces. Okay, litmus solution. From this litmus solution, then you prepare litmus paper. Okay, litmus solution is basically so they get an extract out of this lichen, and they mix it with water, and they prepare litmus solution, which is purple in color. This is purple in color. Okay, and this by mixing it with a acid or a base, they can, and absorbing it onto a paper, they can make it into a red or blue litmus paper, red or blue. Okay, so this is how your lichen is a biological substance is interacting with your chemical substances. Okay, so basically this shows that all science is interrelated. Okay, nothing is mutually exclusive of anything. Next slide will read. A purple dye is extracted from lichens. So extracted dye, so basically dye is a color, okay, that is mixed with water to form a litmus solution. Litmus solution is this purple color solution. In your lab maybe it will be there or may not be, so depends. So you have to ask your lab assistant or your chemistry teacher. Okay. In acidic solution, litmus turns red. In basic solution, litmus turns blue. Okay. So if you take a dropper, this is called a dropper. So you press it, so it absorbs some solution. Then you release it, so it will release the solution. Then again you release it, so it will turn red in acidic, blue in basic. Now if you absorb this acidic or basic onto a paper, you can prepare and then dry it off. You can prepare a red litmus paper or blue litmus paper. I mean, it won't be as simple as just drying it off. Obviously they will have some extra substances to make sure that it functions properly. Okay, so next slide will go. So select the source of litmus solution. You have blackberry. Blackberry is a fruit. grass, obviously grass you can't get. Obviously the answer is lichen. From lichen you get litmus. Okay, lichen based dyes in neutral water. So neutral water is basically, in your lab you will find one white color bottle will be there, translucent bottle, there will be a pipe on top of it, that is your neutral water, okay, in your lab. The correct name would be deionized water, okay. So basically there are no ions present, so if there are no ions present it can't be acidic or basic, it will be neutral, perfectly neutral water. So tap water we get is generally little bit acidic, because our rain, the source from which that water is prepared or brought to our homes is little bit acidic because of gases present in our atmosphere, okay. Next question is, select if the given statement is true or false. Litmus solution turns red when brought in contact with the basic solution. Obviously it is wrong. Litmus solution turns blue when brought in contact with a basic solution if it is of red color originally, and if it is a blue litmus, okay, it is solution. So litmus solution is originally purple in color. So if it is brought in contact with a base, it will turn blue. If it is brought in contact with an acid, it will turn red. So in this case the question is saying it turns red when brought in contact with the basic solution, so it is false, okay. So working mechanism of both litmus solution and litmus paper are the same. So obviously they are not same. Why? Because litmus solution, it turns red. So originally it is purple in color, but it turns red in acidic and it turns blue in basic. So it has a source color, okay. But your litmus paper, it is either red or it is blue, okay. So obviously the way in which they interact with acids or bases and the way by which they depict is if a solution is acidic or basic is different, okay. So purple to red or purple to blue, but in the case of paper, red to blue or red to red, blue to blue or blue to red, okay. And litmus paper is actually prepared from litmus solution. So to make red litmus paper, you mix a small amount of acid in this purple litmus solution, it will turn the solution red, then you make it absorbed on a piece of paper and dry it off. So you will get red litmus paper. To make blue litmus paper, you will mix the purple solution with some base, turn it into a blue solution, then make it absorbed on a piece of paper, it will turn into blue litmus paper, okay. So obviously it is not exactly same, but the chemicals involved will be similar, okay. Next slide will go. Colors play an important role in the world of chemistry. In some cases colors help us to identify whether the solution is acidic or basic in nature. So obviously that is the whole point of using an indicator. Indicators help in by change of their color depicting if a solution is acidic or basic. So three main you will learn in your lab: methyl orange, phenolphthalein, and one is litmus paper or solution. And you might use K-4, potassium permanganate, okay, but that is for a different experiment, that is used in titration. So it can't be used like how they are used. It is used in a reaction in which it itself acts as an indicator, okay. When you are trying to use a self indicator, then you will be using potassium permanganate. Next slide will go. Litmus is a water soluble dye, neutral dye extracted from lichen. So litmus by itself is a neutral solution, okay. It does not have acidic nature or basic nature, it is neutral. When you mix it with water which is also neutral, so it gives you a neutral solution. So neutral, from neutral you can figure out if something is acidic or something is basic, okay. So we will go to the next slide. So litmus papers are of two colors, blue and red. So blue litmus paper if dipped in a acidic solution will turn to red, and red litmus paper if turned to a basic solution will turn to blue, as you can see from here. So question is, a blue litmus paper changes its color to red when dipped in solution of nitric acid. So nitric acid is your HNO3, okay. So HNO3, So since it is an acid, as Shruti was saying, H plus ions are being released. So the litmus chemicals present in litmus solution or paper, they react with this H plus and make a color change if required. So since it is an acid, it will change from blue to red. So it will be true. Okay. Next slide will go. Which of the following chemicals will cause color change in blue litmus paper? So you have hydrochloric acid. So basically to cause a color change in blue litmus paper, you need an acidic solution. So you have hydrochloric acid, which is an acidic solution. We have sodium hydroxide, which is a basic solution. We have water, deionized water or neutral water, which is a neutral solution. So to make a color change, you need an acidic solution. So option A is correct. Okay. Blue litmus paper will change its color in hydrochloric acid solution. The blue litmus paper remains unaffected in sodium hydroxide solution and water, as they are basic and neutral by nature respectively. Okay. Next slide will go. What happens to litmus paper when the solution is a base? So obviously if it is a base, blue will stay blue, red will change to blue. Okay. So these are very introductory concepts for this chapter. So yesterday I taught you acid base, weak acid weak base, strong acid strong base. Then I taught you dissociation, partial dissociation, single arrow, double arrow, what is the significance of the same, how only in water they dissociate. Okay. So all these things I have taught you. So anyway, if you go to learn, okay, so our platform is embibe.com. You guys can visit our platform to practice whatever questions you need to practice. Okay. So if you go to embibe.com, you can log in, sign up and log in, go to learn. Okay. If you go to learn, go to science, select the class. So class can be selected on that right hand side thing. Okay. So here also we have live classes. My classes here are in pure English. Okay. Pure English classes. Next, if you go down, there is books are there. Okay. So books like here NCERT science book. Okay. So we are studying the second. Here less questions are visible, actually more questions are present. So our platform is AI powered, so it will detect if you are able to solve the easiest 3 questions properly. If it detects that, then it will show you more questions of the same topic. So you can solve the questions. So these questions are in text as well as back of the chapter questions. Okay. So you can solve it, and then you can also join our Telegram channel using about to be held. Okay. So guys, thank you for attending today's class. Please attend tomorrow's class. I think tomorrow I will be teaching 9th standard. So we will continue this on next week on Monday. Okay. Thank you guys.
Keep imbibing. We believe in you.